Okay, in this question in part I, we want to express 3x over 3x plus 5 equals to p plus q over 3x plus 5. How do you think we can do that? Rina is not here today. Oh, he's coming. Okay. So how do you think we could solve this? Or how could we express it in the form? What should we do? Any ideas from anyone? No ideas? Jerry, what do you think? What was it that we just covered prior to today's lesson? Sorry? I want to express this into a form. So I'm not going to touch this. So I'm going to start with 3x over 3x plus 5. What could we do? How? What was the method that we learned before this lesson? Don't tell me integration. There are many different skills in integration. What did we learn? Come on, it was such a big deal. I asked what did we learn before this lesson? I said please don't tell me integration. There is much more about integration. Partial fraction, thank you. Okay, so we shall do partial fractions to this. Why? Because they have actually the same degree. Both are degree 1 polynomials. This is 3x, this is 3x plus 5. In this case, you're looking at getting a whole number. Okay, that is the quotient and then the remainder over the divisor. Right? So, what we will do is we are taking 3x to divide by 3x plus 5. So we do long division, in fact, come in. Okay, so we will have 1 times 3x plus 5, so 3x plus 5 minus, in case you forgot how to do long division already, this is what we get. So 3x over 3x plus 5 equals to 1 whole minus 5 over 3x plus 5. That's it for part I. Part 2, we want to differentiate x ln 3x plus 5 with respect to x. So what we will do is our usual differentiation where we apply our product rule. So keeping the left, differentiate ln, we have this. Our coefficient of x is 3, then plus ln, keeping right, differentiate x, we get a 1. So this leaves us with 3x over 3x plus 5 plus ln 3x plus 5. Okay, then in part 3, we want to use the results in part I and part 2 to find the integration of ln 3x plus 5. Okay, so whenever we do integration where we need to use previous parts, and one of the previous parts is to differentiate, what we will do is to just, okay, write the straightforward statement that integration of the answer here. Oops, I forgot a bracket here. Okay, it will equate to x ln x, x ln 3x plus 5 plus c. So this is a very simple statement that you can definitely do and copy. Just write down the reverse. Okay, so we see that our objective actually lies in this statement since you're looking at integration of the ln part. Okay, so what we will do is to extract it out, and by doing so we are essentially taking this integration of 3x over 3x plus 5, bring it over to the right side. So on the right, we will have x ln 3x plus 5 plus c minus away the integration of 3x over 3x plus 5 dx. Okay. So we are looking at trying to simplify the process over here, or rather to continue with the process here. So the integration of 3x over 3x plus 5, we will make use of our answer in part I, where the fraction could be split it into two different fractions here. The reason why this is necessary is because we do not know how to integrate such that there is a 3x, there is a variable on top. Okay, we don't have an integration skill for that. So whenever you have algebra on top, okay, of any algebraic expression at the bottom, and you need to integrate that, okay, we got to make use of partial fractions. Okay? So therefore this one becomes 1 minus 5 over 3x plus 5 dx. So the integration of 1 is x. Do remember to put in the brackets here so that we can solely focus on the integration. Minus away 5. I'm taking out the 5. We're looking at integration of 3x plus 5, so ln 3x plus 5. Remember to divide by coefficient of x. Then you can do your plus constant on the outside. It really doesn't matter whether your constant is inside the brackets or outside the brackets, okay, because that is not our objective to find out now. Okay. Then we simplify it. So we have x ln 3x plus 5 minus x minus 5 over 3 ln 3x plus 5. You may want to just simply convert the plus c and plus d into a plus f. Okay. You could change to factorize it if you like to. And arrive at this. But this will be the simplest that you could ever get. Okay? Yep. Why is it minus? Minus what? Oh, sorry, I've lost right. Yeah, plus. just do the differentiation part first in part I. Differentiate this, okay, and try to achieve that. I give you about 5 minutes to work on that, okay? Then in the meantime, I'll give out some of your homework. get it? Alright, let me distribute out all this first. If you're done, you may want to try part 2 to see if you can manipulate it well. Okay. Alright, let's work it out. Okay, so you're expected to use your quotient rule. So in this case, actually before you use your quotient rule, you may want to, in fact, consider bringing down the 3 to express it as 3 ln x as well. Okay, but if you didn't, that's also fine. Okay, because if you actually brought down the 3, you could have actually bring out the 3 and focus on just differentiating your ln x over x squared. Okay, so that might help a little. So, oops. In differentiating using your quotient rule, we keep the bottom, differentiate the top, ln differentiate becomes 1 over x, minus away, keeping the top, differentiate the bottom, which is 2x, over bottom squared. Okay, then we look into simplifying this. X squared times 1 over x is x, minus 2x ln x over x to the power 4. So we're getting close to the answer. 3, you can factorize out the x. And then can cancel out. So we arrive at this. Then we can split up the fraction to have 1 over x cubed minus 2 ln x. 2 ln x essentially is ln x squared. Therefore, we arrive at the answer. Okay? So, in part 2, again, we are asked to integrate something, okay? And then in part I, we actually differentiated, right? So we make use of the answer from part I. So, it will tell us that the integration of 3, 1 over x cubed minus ln x squared over x cubed, dx will be equals to ln x cubed over x squared plus c. So this is the bare minimum that you have to write, okay? And you know and capable of writing it as well, okay? Then we notice that what we want as an answer could be found, okay? Or rather, the thing that we want to integrate could be found around here. Agree? So we need to do some manipulation. In this case, it is a 3 times something. 3 is a constant. We could put it out of the integration. I would suggest that when you have to do such manipulation, do it step by step rather than multiple steps, many steps going on at the same time. Okay, I don't encourage that. Then we can divide the 3 over. Ln x cubed over 3x squared. You may want to put c over 3, or if you don't like the ugliness of a c over 3, feel free to convert it into a d. Okay. Then we can now split this integral into two parts. And we're getting close to the answer. Right? You can choose to integrate here directly first, okay, for the integration of 1 over x cubed. Or you may want to just manipulate fully first. Okay, when manipulate, be very careful of what you're bringing around. So, if we choose to integrate it here, integration of 1 over x cubed, what would the answer be? What would the answer be for integration of 1 over x cubed? Chloe, what do you think? What is the integration of 1 over x cubed? Ln x cubed. Then plus c. We have already used c, so maybe let's choose a plus c. Any objections from the class? Let me just copy the rest of the things down first. Any objections? Bernice?
X minus 2 over
X minus 2.
x to the power of minus
X to the power of negative 2.
over negative.
So, you're saying that integration should x power negative 2 over negative 2 plus d. So what is right? So Chloe, now that you heard what Bernice has shared, any second thoughts? You want to retry your answer? Or you say that your answer is correct? No means taking back your answer? Okay? So like I mentioned yesterday, be very careful when you're dealing with 1 over x and all that, okay? Because when we have 1 over x cubed, okay, it is actually integration of x power negative 3 dx, right? So this one we use the power rule of integration. We add 1 to the power, divide by that new power. Remember that? Okay, so please don't get lost and so overwhelmed by the whole integration of 1 over something and then you give it a lot. Okay, so that is a really very common careless mistake to fall into. So let's correct this one. It should be a x power negative 2 over negative 2 plus d. Okay, since you add it, for this ln x cubed, you may actually change it into a power 3 bring down. You can change it as 3 ln x as well. The power could be brought down because this is just the only thing for the function x. Okay, so we just bring it down here. Then we can actually cancel the 3 away. So it may save us a bit of work. So now it's about moving things. Okay, so we have a negative 1 over 2x squared plus d minus away ln x squared over x cubed dx equals to, let's simplify that to this. Then I will have, so I'm just writing a line across to differentiate, otherwise it might be messy. Then move things around, so let's move this up here, this one down. So negative 1 over 2x squared minus ln x over x squared. We have many constants going on already, so let's just put a plus f. Okay, so the integration of ln x squared over x cubed is equals to this. Okay, there any way to further simplify this? I don't think we could. Yeah. Okay, you can give your answer in this manner. So this is the answer. Okay. So focus on one thing at a time in each step. If you want to integrate, just focus on integrating. If you want to manipulate, then focus on manipulating. Don't be greedy and don't be trying to rush for time. Because as you do that, you may fall into a lot of careless mistakes. And then lastly, in part 3, we are given that y is a curve fx. Okay, f prime x is actually ln x squared over x cubed. That is actually what we integrated in part 2. Okay, so to find out what is fx, essentially it is already this, just that I must find out what is the constant. Okay, so my fx is negative 1 over 2x squared minus ln x over x squared plus f. At 1, comma half, substitute the point in. Half is equals to negative 1 over 2, since x squared is 1, minus ln 1 is actually 0. So f is actually 1. Okay? Therefore, fx will be negative 1 over 2x squared minus ln x over x squared plus 1. And that's all. Okay? That's it for chapter 16.3. Very last homework before your year exam. Next week, Wednesday. Very first. Okay? Questions? Alright, so that's all. Chapter 16, we're done with the syllabus for mid-year exam. Okay? So we are kind of done.
So after mid-year got what topic?
3 chapters. Your definite integrals, your kinematics, okay? Definite integrals, area under the graph, kinematics, as well as plane geometry of proofs. Yeah, I think that's what the chapter is called, plane geometry. Okay, the very last one is a proving chapter. I will just say, if you get it, you get it. If you don't get it, so be it. Okay, don't spend too much time on it. Alright, so I rather you spend more time, okay, on your calculus. A-maths is really a lot of things on calculus, otherwise trigonometry. In fact, if you have thoughts of going to JC and you want to do H2 maths, right? Okay, calculus is the main part of it. Okay, no longer doing so much of your partial fraction, your cubic equation solving and all that. Okay, one last homework to distribute out. Esther, could you do me a favor? Distribute the files, please. Thank you. Okay, just want to finish distributing homework before I talk about your homework that's due today. Maybe you can help me pass it to Anita, please. And Go ahead, okay, you should have received back exercise 13.2.4, 14.1 and 14.2. Okay. Oh no, I erased the little hat.
Quite funny.
Okay, exercise 16.1. Any issues regarding the homework? If this is a question 3. Issues in question 3? How about 4B? 4D? Okay, 4D, 4F, 5B, 12, 13, okay, 15, 17, okay. How about 16.2, question 2, question 3, question 5. So 16.2, no issues. Question 5. Okay. Okay, exercise 16.1. Question 13. Part I, are you able to differentiate? Okay. Are you able to differentiate question part I? Yes? No? Okay. So let's differentiate it then. We use our product rule, chain rule. Okay. So actually don't have product rule, sorry. We will use our usual chain rule. So differentiating this one, we can ignore the 1/5 in the sense that we just put it aside. Differentiate this, bring down the power. Keep the base power minus 1, so 3/2. Differentiate the inside, we get a 2. Okay. Then, for the second one, put aside the 1/3. Bring down 3/2. Keep the base, power minus 1, we get a half. Differentiate 2t plus 1, we get a 2. So that's the differentiation process. Simplifying, cancel, 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 cancel. 2t plus 1. This one also, cancel, 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 cancel. 2t plus 1, the power of half. Okay, you may want to simplify this. This is actually meaning to say 2t, you can factorize, okay, 2t plus 1 to the power of half. What we will be left with inside here is a 2t plus 1, because this one times this one, this is the power 1, this is the power half. 1 plus half is 3/2. Okay. Minus away, this one already taken out, so minus away 1. Okay. So simplifying, 2t plus 1 minus 1. So it is just a 2t. And in other words, 2t square root 2t plus 1. Okay. Part 2. Hence or otherwise, okay, we want to integrate this. Therefore, in order to integrate, you need to have gotten this up. Okay, so if you're stuck halfway, you need to think about this. You can think about your part 2. How is it that this can help your part 2? So that's why it might draw you towards trying to factorize. Okay. So to use our part I's answer, we just write down what we know first. Integrate this answer, we get back the original. And remember to plus C. Okay, then because we're trying to integrate this t, you don't have the 2. So actually 2 has been taken out. Then we divide the 2 over to the right side. Okay, you can leave it as C over 2, or if you want to change it into a D, that's perfectly fine as well. Okay, questions? Next, question 15. I erased part I already, yeah? Question 15. We are given the second derivative. It says the equation of the tangent to the curve at the point 1, 4. So always draw it out. Tangent to the curve at the point 1, 4. Okay, this line has the equation y equals to 5 minus x. We want to find the equation of the curve, so need to integrate twice. So that means your dy over dx is to integrate 1 minus x squared. We get x minus x cubed over 3 plus c. Okay, to get y, integrate it again. So x squared over 2 minus x power 4 over 3 times 4 plus c x, plus d. Okay, then now at 1, 4 itself, we know that the gradient of the tangent can be extracted out of the equation of the straight line of tangent. From the equation of straight line, y equals to mx plus c. This is 5 minus x, so gradient is negative 1 from the equation of the tangent. So that means that dy over dx is equals to negative 1 when x is equals to 1. You can go and do the calculations. C will be equals to, what is C? Negative 1 and 2/3. Okay, so if c equals to negative 1 and 2/3, now we need to find out what is d. So that means at 1/4 as well. Y is 4. C we have already gotten it. So go and do the manipulation. D is 5 and 1/4. Therefore, y will have the equation x²/2 minus x⁴/12 plus c is negative 1 and 2/3. Coefficients should always be improper fraction. Okay, so that will be the answer for question 15. Question 17, our second derivative is 6x plus 3. Gradient of the curve. Okay, again, got a curve. Then gradient. So that means got tangent. This gradient is negative 18. Point here is 2, negative 60. You want to find the coordinates of the stationary point and the nature. Again, integrate twice. Okay, since we are told the gradient at a certain point, so that means that, write it here, yeah? At 2, negative 60, your gradient dy/dx will be equals to negative 18. C will be solved to achieve negative 36. Okay, then put it into y. So at the same point, y is negative 60, x is 2 cubed plus c negative 36, x is 2 plus d. So d would be found to be negative 2. Therefore, your equation of the curve will be x³ plus 3/2 x² minus 36x minus 2. Question asks us to find. Oh yeah. Okay. So we need to find out this because question asks us to find coordinates of the stationary point. So we need to eventually find y coordinate. So dy/dx equals to 0. That means your 3x² plus 3x plus c, that's negative 36, equals to 0. Factorize. There are two values that give you stationary point. Substitute this into your equation of curve. We get 102 and negative 69.5 respectively. So at this point, find your second derivative value. Substitute into the original question. That's negative 21 less than 0. So therefore, this is a maximum point. Okay. Then, likewise, second derivative is more than 0 for this point, so therefore it's a minimum point. Okay, sorry that it's a bit messy and disorganized. Okay, so exercise 16.2, question 5. With part I can do differentiate. They asked to differentiate this one. Can do. What do you get? Two x plus 2. Cosine x squared plus 2x. Yeah. Okay, so part I, when you differentiate, you should get the answer 2x plus 2 cosine x squared plus 2x. Okay. In the question in part 2, they ask you to integrate this. Okay. So we apply what you already know for part I. That would be to integrate 2x plus 2 cosine x squared plus 2x. We are going to get back the original sine x squared plus 2x plus c. The difference between this statement with the original question is that this is a 2x plus 2, this is an x plus 1. I hope that you can see the link that can be factorized. This one factorized out of 2. Leave it outside the integral because after all it's a constant number. So what we'll do is to divide by 2 over to the right side. You can change the c over 2 into a d, that's fine. Okay. So that's all for your 16.1 and 16.2. Alright, submit your homework to the front, please. Yes.
I thought I said it before. I'm sure I said it that day.
Because I told you all can put in same footstep, right? Yeah, staple it together. Thank you.
because I'm not sure really.
Okay. Okay, next, let's go through the homework that I've just written to you. Just a few mentions of stuff, that's all. Because after all, before you submit, I always say some stuff already, go through some stuff already. Okay, first one is your exercise 13 point, what 13.2? It's 13.2. Okay. Right, for 13.2, this is my feedback. Mark it a while back. Logical thinking process is mostly incorrect. Okay, what does this mean? Okay, it means that the proof that you have given in exercise 13.2, whereby the topic, okay, the question is found on page 31. It is your increasing and decreasing functions. Okay. The question, for example, question 4, whereby a function is defined to be this equation, show that it is increasing function for all real values of x except, by right it should be x equals to -1, not equals to -1. Okay, so we want to show that it's a decreasing function. That means that, okay, I want my main objective at the end to be dy over dx more than 0. Okay, and the conditions given to us is that it's all real values of x except for x equals to -1. So most of you can differentiate, no problem. Okay, but the exponential part, this section is the one that is very, very confusing and very messy for a number of you. Okay, we want objective to be dy over dx more than 0. How to explain? We make use of the conditions given, that for all real values except x equals to -1, this part, the denominator, where there's variables, is more than 0. Because this is more than 0, the entire fraction would then be more than 0. That's why we have this. Okay, I hope that you're able to draw the comparison between your work and my work over here and understand the logical differences in what you have written and what we have here. Okay? So that's for question 4. I think the crucial part will just be this. Differentiation, I would say, usually shouldn't be an issue for most of you. Especially by now. Okay? Then, question 5, for instance, it is different in the question asking. Okay? I'll just flash the question first, yeah? Question 5, it asks to show that fx is increasing. Oh, sorry, it's actually similar in question asking. Wait, oh, no. It's different because the question says find all the intervals. That means find all the values of x. So question 5 is asking you to find the x value so that x is increasing. But question 4 is to tell you that why is the function increasing for all the x values. Okay, so it's a different, okay, it's opposite the other way round. That's why for question 5, differentiate also. But then, because the question's condition is that it is an increasing function already, so this one, if it's going to be more than 0, what are the values of x that will turn out? We can divide by 4. Then, for this cube to be more than 0, the x plus 1 must be more than 0. If it is less than 0, then the cube of it will be negative. So it is a logical deduction instead of algebraic manipulation of any sort to progress from this step to this step. It is not about taking cube root, it is about a logical deduction. I hope you understand what I mean by logical deduction, yeah? Okay? So for example, 2 cube is more than 0, but negative 2 bracket cube is negative 8, which is less than 0. So that's why the base must be more than 0 here. Then we move the plus 1 over to the right lah. Then x is more than negative 1. That's why x more than negative 1 give you increasing function. So I hope you can draw the comparison between question 4, question 5. The demands are different. So the presentation will be different as well. If you don't understand what I'm saying, okay, please go and work out the question again. Alright, I will send you my full work solution. Okay, I'll drop it onto WhatsApp since that's the preferred mode. Okay, then please go and do the questions again as you practice. Okay. Next, 13.2 is done. 13.4. I seemingly have no comments. I suppose because the typical questions I have gone through in class already. Yeah. But does anyone have issues that you want to clarify from 13.4? Okay, which is your connected rate of change? Okay. For connected rate of change, I would say maybe just go and practice, okay, questions. So, and you'll get a hang of it. Okay? So I'll not talk more about 13.4. 14.1. My concern is question 3 part 2. Let's see what's the question. Question 3 part 2. Oh. This is the question. That's on page 57. Find derivative, no problem. Part 2. Explain whether this curve has a stationary point. So for there to be a stationary point, dy over dx must be equals to 0. So you do your dy over dx already. Arrive at this. It's a bit blur. Okay. Then, why we need to explain. Is it possible for this thing to be equals to 0? It's not possible actually, because the variable is in the denominator. No matter what you divide by for any number, so in negative 7, divide by whichever number, you will never ever get 0. But of course, that is a very simple term, okay, that you can tell to a kid. You cannot say that in exam, okay, it needs to be rigorous. So, we say that because the denominator is always positive for all real values of x, except when x equals to negative 2. Okay, we cannot have x to be equals to negative 2. Okay, for x equals to 2, for x not equals to 2. Okay, because if x is equals to 2, your x minus 2 is 0 already. Then your function is not defined. You will never ever get a function. Okay? So because the square is more than 0, this entire fraction, negative number divided by positive number will give you negative number. So dy over dx is always less than 0. That's why the curve does not have a stationary point. Then for 14.2, I have no comments as well. Okay, maybe just a short comment. Not sure whether you remember 14.2. We had this question, the one that hold the paper on. This one. This is on page 64. Okay. Then I remember I took a very long time to explain this in terms of x. I saw some of your working. Some of your working right upon the similar triangle. Okay. You wanted to make use of how ADE is similar to triangle ECF or something like that. Okay, there are a few of you who did it via similar triangles. However, there was no proof that they are similar. Okay, if you want to use similar triangles, alright, it got to be very obvious that maybe AA similarity can work. I went to try, I went to prove, my proof is wrong. So I don't know how, okay, for those that try to do similarity, okay, I have no idea how do you go about spotting that similar triangle. If you have a shorter proof, please let me know. Otherwise, I would have marked it wrong. Okay, and you may want to consider looking at this method that I've written here. Okay? That's all that I want to say about the 4 pieces of homework I've given to you. Last thing that we'll do today is for me to give out the 2018 papers, and then we'll just call it a day. I'm sorry? Joseph, for a person that doesn't do homework at home and do it in school, it is no longer called homework. Okay? I don't know what is your definition. Yeah. Until you know that homework is to be done at home, then yes, it is homework. Okay, for giving out paper 1 first, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4. 1, 2, 3, 4, 5, 6, okay. So that's paper 1. For paper 1, because my version is different from yours, I don't know what was sent to the printing. I didn't send it to printing. It's done by another teacher. Just spot, okay, not in syllabus, not in FYE. You may want to cancel those questions out first. Six, 7, 8. Sorry, what do you say? If it's not there, then okay, so be it. Yeah, because I have the full original paper. I didn't check sure what was written for you. This is paper 1. Okay. Okay, paper 1, paper 2. Paper 1 on the left, paper 2 on the right. Yes. You have a 1 missing paper 2. Does anyone have an extra paper 2? Can you please just check? It might be stapled or attached together. Don't have? Okay. Is that extra? Just extra? Okay. Just take a look. Okay. For next week, I'm going to go through 2019 paper. So next week, week 5, that's on a Wednesday. So AMATS, I'm going through 2019 MYE paper 1, right? That's what I mentioned. Okay. For paper 2, there is a graph question for 2019 paper. There's a linear law question. Please, I beg of you to go and draw your graph up. Okay? Draw your graph, go and practice your graph skills. Don't let it rust. Okay? You are made of human flesh. You are not made of metal. You should not oxidize. You should not rust. That's why you should try to do homework. Say again? Yes. Okay, alright, then